Well, I think we're live. Well, it took us a while, but hopefully everybody sees us. Yep, I see the participants racking up over 100. So hey, everybody, I'm Ben Gromicko from InterNACHI. Sorry for the late delay, but trying to use the new webinar system. And we have a special guest today doing a webinar, and that's Paul Roebuck from TPREIA, and he's from Texas, and he's a partner and a master inspector and a master instructor. And Paul is going to teach us a little bit about common electrical defects that we home inspectors may see during a home inspection. And Paul, I thank you for your time and joining us here today.
Certainly, I'm glad to do it.
And whenever you want to take over the screen, you may.
Okay, let me get my screen going here and let's see if we can do it. All right, there we are. Well, hello, everybody. I'm glad to have you guys on the program with us today. We can share this. I won't be able to show you every common deficiency that we find, but I'm going to share a lot of them that as inspectors over the years, it seemed like some of this stuff gets to be repetitive during a home inspection. And some of it is stuff that you may just see and never think anything about it. So let's go into some of this and see how much we can get covered and just show you some things that I found in my over 27 years of doing home inspections. Okay, I'm going to tell you now that, you know, I've been doing this a long time, taught a lot of classes to a lot of inspectors. And my findings over the years has been that electrical is probably one of the most needed advanced teaching classes that we could probably offer to inspectors. It seems like that's the weakest area that most inspectors have, unless they come in from being an electrician. But today I just want to highlight some of those multiple deficiencies that are common in my area and probably in yours too. This is not an all-inclusive show to show you every little deficiency you'll find. It's impossible to do that. This brief presentation will illustrate several of those commonly found wiring issues. One of the most important issues for home inspectors is that you be safe while you're fooling with anything electrical, because it can hurt you, it can injure you seriously, or it can even cause death. So when you inspect an electrical panel or any panel board, you want to always take that right hand and just kind of touch the back of the face of that panel. Just reach up and touch it quick and get off. The reason you want to do that, because if that panel is electrified, if you touch it with the wrong hand, it'll pull you to it, or if you go hand palm down, that electricity you'll grab and it could kill you. So be extra careful on that. But that's one tip you never want to forget or overlook when you're touching any electrical panel board, a disconnect at an air conditioner, anything similar to that. First, let's look at some of the InterNACHI standards of practice we've got. The InterNACHI standard says the inspector shall report as in need of correction deficiencies in the integrity of the service entrance conductor, insulation, the drip loop, vertical clearances from grade and roofs. You'll report any unused circuit panel, breaker panel openings that were not filled, the presence of solid conductor aluminum branch circuit wiring if readily visible. And electrical, a lot of times, whenever I report something, I'll put like identifying the wire type or something, I'll always put where visible. That's a good term to remember in your reports, because you can't report on something that you can't see, and you don't want to assume that there could be something else there or that there's not something else there. But you need to report any tested receptacles in which power was not present, polarity was incorrect, the cover was not in place, the GFCI not properly installed or didn't operate properly, any evidence of arcing or excessive heat, and where the receptacle was not grounded or not secured to the wall. And then the absence of smoke and carbon monoxide detectors. And we'll cover just a little bit of that as we go through this presentation. Electrical systems are dangerous. That's the first thing we need to remember on any electrical system. Home inspectors come from a variety of backgrounds. I know that the range of experience varies greatly from oil field to medical to whatever. I mean, there's just so many different backgrounds out there that a lot of us, this was a second career for us, or even a third for some. But the foremost thought of inspecting electrical system is always to be careful and safe. This brief webinar today will not teach you everything about inspecting electrical system. We're not even going to be able to provide you every example of things to call out as a deficiency report. But we are going to show you some of the things that are common that we find, that I find, going out doing inspection. Now here's a picture of a panel board, and if I open it, took the dead front cover off. Look at this panel board. Yeah, question is, how many wires can you attach under one screw? This is a common question that I get asked at teaching classes. And on most electrical panel boards, they only allow one wire per screw. There are a few exceptions. There are some panel boards that where the screws go in, it'll have kind of a double U-shaped connector where it can allow two wires. But most of what I see, probably 95% of all single wires. So the reason you don't want multiple wires under it, you can't tighten that screw up tight enough to prevent arcing on those wires. So that it should be considered a fire hazard if you look at these. So some of the stuff I'm going to show you is stuff that, as an inspector, you should be common knowledge enough that you, if you open the panel board, you see something immediately. If you notice the lugs there, look at the main lug on the left and then the two next to it. See all the multiple wires shoved in there? That's a fire hazard waiting to happen. The other thing that you should notice almost immediately is a solid wire aluminum wiring. We have to report those as deficiency. And aluminum wire houses, I always write them up as a deficiency because a lot of them are considered to be fire hazards. That's a big one. I mean, it may not meet our standards of practice, but it's a good thing to CYA for yourself on aluminum wiring. So just a thought on that for you. Yeah, look at this picture here. Now, you don't mind, tell me how you would write that up. I don't expect you to answer me. I don't have time to answer each of you, but just, you open a panel board, this is what you see. Well, get that tablet out and start writing, because this is a damaged panel board. It looks like something's arced. Looks like something's been wet, perhaps. At that stage, I don't really care what the cause was. I am just the reporter. I'm reporting what I observed, and seeing this, that's not right. So don't spend an hour trying to figure out what happened to it. Just write it up as a deficiency and move on. Now here's some more. This is something we see commonly. This is just an exterior panel board and it's rusty. According to our National Electric Code, and if we find a panel board that's rusty, you can't paint them. So how do you fix them? You upgrade them. It gets to be tough. I mean, you don't want to just candy coat this stuff for people, but when you have one like this, it can be dangerous. But the other thing, just quickly glance at this panel. You can see it's going to be an old one to start with. So it could be an aged unit that updating probably would be good for them. But the only label on the breakers says AC. So every breaker has to be labeled. Okay, here's another. This was a newer construction. Dead front cover off, looking at the panel board. You see all the white stuff splattered all over this panel board? According to the National Electric Code, that's considered to be what we call contamination. Contamination can be paint overspray, texture overspray, dirt, junk, anything in there, sawdust. That panel board is supposed to be clean and have no contamination. So when you see one that has this type of condition inside, it should be a deficiency on your report, because that is considered to be a fire hazard according to the National Electric Code. So, I mean, they can't really clean this thing. Once it's messed up like this, it's time for a new panel. Who did it? Wasn't the electrician. The electrician, you see the wires for the most part, looks pretty good in this panel. It was the painters. Yes, sir.
Jeremy asked about that rusty panel. Did you open that one? Would you even open a rusty panel?
Yeah, I'd open it. Yeah, that's, you know, as long as the panel board's not making any buzzing sounds or it's not hot when I touch it, then yes, I'll open them. Some of them I've walked up to that sound like you got a bunch of bees inside. Usually it's not bees and it's not wasps, not all the time. I have seen that too, but it could be that panel board just about to blow up because it's shorting out on wires. At that stage, if I find that situation, I would immediately call the listing agent on that property and say, hey, we have a fire hazard condition. You need to send an electrician out immediately, because that is an issue. But that's a good question. But yeah, I'll open them up unless I have something like that really I can tell from the get-go that I don't want to open it.
And Fred asks, what is the problem with having neutrals and grounds on the same bus bar? It isn't a problem in the main distribution panel, but it is in the sub panel.
That's going to depend. That depends on how the bar is connected.
Yeah.
If you have a panel board that has two bus bars, one on the left, one on the right, let's say, and then you have a bar that connects the two together, it doesn't matter if the neutrals and grounds are on the same bar.
Yeah.
But if it doesn't have that connection that connects those two bars, then it has to be separate. Grounds on one side, neutrals on the other. Okay, on this one, you can see again the multiple wiring connected underneath the bus on this one. And I mean, how do they fix that? They add another bus bar to it, and they can do that and connect them and then have more space on it. This is just overcrowding, but again, if you look at the wires close, you notice how excessive wire, notice down towards the middle of my picture where the wire goes through the screw and then touches the panel board itself. Yeah. I mean, that right there could be an issue. It could cause that panel board to have some electrical current flowing in it. Okay, here's another one. We got a lot of contamination to this thing. I mean, this is just a real typical job on maybe you see new construction when the electrician didn't cover that during the construction phase. Another one is all the wires. If you notice all the wires coming through the big holes up on top of that panel board. Some cities allow that. I know City of Houston still will allow that. As an inspector, when I find this in a home, I'll write it up because the wires are not secured to that cabinet. That is a National Electric Code requirement. I'll show you an illustration here in a few minutes. But you know, this is something that's done. I mean, I see it commonly. I mean, it's not anything unusual at all to see it. But the code says it's a violation because it doesn't connect the wires to that cabinet. You can't clamp that many wires to it. And that's we traced that back in me and my master electrician as a consultant, went back to the early 1950s in the National Electric Code. It's been a violation since way back when. But again, it's common, you probably will see it. Here's another fine example. See those little, look like circle areas on the top right and left of this screen? Those are where the wires are supposed to come through and have a little clamp that holds that, secures those wires to that cabinet. This many wires, a lot of inspectors would call that bundling. That's according to the code, that's not what bundling would be called. If it's outside that box and they tie them together, yes. But this is an improper installation because the wires are not properly secured to that panel board cabinet. This is how they should look. If you look at this picture, see how the wires come down and connect? That's what I like to see. I'm starting to see it. We've written it up so much in my area of Houston and all around and taught inspectors. This is what we're starting to see a lot of. The panel boards are really looking a lot better. So, you know, that's just something you open that panel, you see those wires bundled or collected all at one spot. That's a deficiency in my book.
Paul, a few inspectors are asking, should they even open up the electrical panel? What is the point of opening up the electrical panel? It's hazardous. So why would they ever open up a panel board?
That's a good question. And in Texas, the state requires we open it up. Your area may not require. I know that the InterNACHI standards do not require, if I'm not mistaken on that.
That's right. That's right.
The reason you want to open that panel board up, as I was showing you some of those illustrations as we went through the slideshow, you can see some of the stuff inside. If you don't open it, number one, you're not going to know the wire size versus the breaker size. You're not going to know if the wires have been burnt or if there's a breaker that's overheating. You're not going to be able to know if the wires was properly installed in that box. And you're not going to know if it's aluminum wire or copper wire. I mean, those are just a few things off the top of my head for you. I would suggest taking that cover off, but do it very carefully. If you're not experienced enough to do it, then I would ask you to probably find an electrician or another inspector in your area that could, and take a little training on it. Let them work with you and show you some of the pros and cons of doing it to keep you safe.
And there's that other point too, where, you know, InterNACHI's standards of practice is the national standard, but you've got to comply with the local regulations. Your state or local regulations overrule anything national. So if you are in a regulated state like Texas, you have to abide by the state's rules, right?
Correct.
Yeah.
That's correct. So it will vary from state to state, but I mean, I'm just giving you some general basic stuff that, you know, that we use in Texas.
Okay.
But questions, keep them coming. Okay, watch for improper screws. And if you go to a panel board, if that dead front cover, if you can't use a screwdriver to unscrew the screw, you're probably going to be something that could be hazardous to you. For instance, if you have to have a nut driver or a pair of pliers or a socket to unscrew those screws out of that panel board, I would tell you to be real careful on them. A lot of times you can get them out okay, but putting them back in, I typically won't even put them back in, to be honest with you. I'll carry extra screws in my bag, carry on my waist, and I'll put some other screws in, take pictures of the ones I took out, and tell them they need to put some proper blunt-ended screws in. Now, why would you not want to put those back in? I have seen many of them that are what we call self-tapping screws. And those will screw through metal once you get it started. But you put it in, long screws, short screws, but they're pointed, and you put that cover back on that dead front, tighten those screws up, you could penetrate a wire, and before you know it, you've caused a fire, and you could have gotten electrocuted. I've actually seen, I had an engineer work with me. We was doing an apartment complex, and I had taken the covers off in a unit, and we inspected it, we discussed it, and we were putting the cover back on, and they had pointed screws. I told him, I said, now when you put these screws in, you be real careful on it, because I'd already pushed the wires out of the way where the screws weren't supposed to hit it. But I told him, I said, don't tighten them all the way up, just snug them. You know, meaning just as tight as you get it without it being loose. Well, I was in another unit, and all of a sudden I heard a kaboom. And I thought, uh-oh, I lost an engineer. So I go running over to where he's at, and the guy was standing there just shaking. He said, I got shocked. I said, well, thank God you're alive, you know? I said, I told you, be careful doing that. So, I mean, that's just a humorous story, but it was a serious one. So be careful, because they will bite you. All right, let's move on. Here's another one here. If you look at the picture, you can see the feed wires coming in. Those are aluminum wires. Now, in Texas requires inspectors write that up as a deficiency if they don't have the antioxidant compound put on them. The way these wires are installed, when the panel board's first put in and we actually bring those feed wires into it, those are coming from the meter, so they are always hot. What they do, the electrician loosens those two lugs where the wires are slid into, put the antioxidant on those wires, shove those wires down in there. Shouldn't be any exposed wires above those lugs, and you see on this one they did. Then they tighten those lugs up, and they actually torque them. They have a certain torque that they have to tighten them up to. So once the house is built, the wires are in, the electrician's gone. If they have to come back and put antioxidant on it because we wrote them up, they just come in and kind of brush it on or slap it on or something. It looks real gooey looking. But if you ever see that antioxidant compound on those wires and it's oozing all out, it's bubbling all out on the sides of the wires, I write it up as deficiency, because if that stuff drops down onto the rest of the breakers in that panel board, you could cause a fire to occur. So, I mean, it's when you see it, it's just sloppy electrical work.
And everyone's calling out the mud wasps. I don't know what you want to call them, but they're not supposed to be in there either.
No, they're not supposed to be in there either. No, they sure are not. If you got an outside panel board that you're opening up out in the rural areas, and if it's got openings in that panel, I would tell you to be real careful. I've opened one before and found me a live snake inside the thing. Of course, I let him have it real quick and I left. But you know, you don't know what you find. I opened one day and there was red wasps that come out of it. I mean, there was thousands of them. And the lady at the house next door, this was just normal city lots, sitting on her front porch, and she started screaming because I ducked and hauled tail when the wasps came out, and the wasps went over and they were all over her. So she was blaming me for the wasps. But I had a pest control guy there with me, and he was fortunate enough to have stuff to take care of those wasps. So yeah, you never know. I mean, you open a panel board, you take that dead front off. I tell people it's like a box of chocolate. You never know what you're going to get. Okay, another main thing, if you look, and this is something that I'll just, you know, when you see a panel board or disconnect device, like out at the AC system, even if it's an electric water heater, anything like that, there has to be that minimum clearance in front of us, 30 by 36, and that's anywhere. One of the biggest things I find is disconnects behind the air conditioning condenser. And I'll show you a picture of that in a minute and a code illustration of what it should be. But the clearance is very important. This means you can't put it in a closet normally, especially a closed closet. If you find this in a closed closet, like they did a lot of older homes, that's considered to be a fire hazard. I mean, if they put clothes in front of this or anything else that could catch fire, then that's a hazard on it. So this is an easy write-up many, many times while you're doing an inspection. What about this one? How much clearance do we need? 30 by 36. You could get it on the middle one, maybe if you stretched it just a little, but that left one, you got no clearance at all on it. What are they going to do about it? If you write it up, they're not going to fix that. I mean, it's, you know, our job as inspectors is to find deficiencies and things that, you know, are not written or installed correctly. This would be one that's not installed correctly, but all you can do is tell them. I mean, the homeowner's not going to fix it for them. So, you know, but if you don't tell them, then you got a liability. It could come back to you someday. So it's best to just report what you see and understand that everything you put on a report doesn't mean people's going to correct them. I've gone back to the same house 2 or 3 times for different buyers over the years, and they're never corrected. So, you know, it's just write them up. That's all I can tell you.
Paul, we've got a couple questions about code. So you showed an illustration that refers to code, and home inspectors are not code inspectors. So right. What's your take on home inspectors making recommendations like this one? So some folks are in places where there aren't panels outside, like in Pennsylvania. Most of our electrical panels are inside. So those are 2 panels there right next to the meter. And you mentioned about clearance, especially to the one on the left there, the wall. How do you write this up and comply with the state rules, since you're not a code inspector, you're just a home inspector?
Well, it depends on your state rules as how they do it, but I can only tell you what I do personally. And I will quote a code as a reference. The reason I do that on my reports, I used to not do it years and years ago, but I started doing it because by giving a code reference, you don't have to be a code inspector. You're not trying to enforce a code. All you're doing is referencing a code. That makes it a lot easier when someone says, well, that's just your opinion. Well, really? If you give them a code as a reference, that took your opinion out of the picture and put it right back on them. So, you know, I've had realtors many times say, well, that's your opinion. Or an inspector will call me and say, Paul, I got an electrician argue with me. He wants to know, where did I get this from? Why am I writing it up? Well, the only thing we can do is base it on building codes. So your state, it depends on what building code you're under, but you could certainly look that up through icc.safe.org, and you could see the codes that's required in your state as minimum. I know in the state of Texas, Texas adopted codes, and the entire state, whether you're in a county or what, is under the 2015 International Residential Code. I'll get builders in counties where they have no code enforcement, And they said, but we don't have a building code. And I have to correct them and say, oh, yes, we do in Texas. So in your area, it would be just finding out what code your state is in and if the counties are included in that. But normally the building codes are just minimum building standards. If you have a builder that builds exactly to the codes all the way through, then they're probably just considered a minimum builder.
Yeah, and in reference to code and being a home inspector, InterNACHI school, that's the home inspector college accredited by the U.S. Department of Education in Canada. We based all of our training on code, actually. So when the code changes, all of our curriculum gets reviewed and revised if needed. So InterNACHI's training, the online courses that are free to InterNACHI members, they're all based upon the most recent code. So if you go through the courses, you'll see references to code, because from that foundation of code, you get trained on becoming a home inspector, which is a heck of a lot easier. So code inspectors, I got code. I mean, in my personal library, I got code books. So code inspectors, they have to, like, when they're doing inspection, they have to refer to the code specifically, and they can't go beyond that. They have to look at the code and inspect according to the code. But as home inspectors, it's a lot easier. We don't have this in our hands. We don't have to quote code. All we do is we kind of side on our client's side. We're on the client side, and they may have needs and general concerns about things, but we can refer to code, like Paul said, but we're not code inspectors. So we can make recommendations based upon our opinion and have a foundation in code.
Correct. Yeah, and knowing the codes just makes you really a better inspector, in my opinion, because you're better informed, you're more knowledgeable on it. And whenever you get out there and some builder says, no, that's not code. Well, if you've got the code, then you've got something to back it up with. Yep. And many times I've had discussions with electricians and tell them, you're not supposed to do that. That's a code violation. And they'll say, no, it's not, Mr. Inspector. And they'll frustrate me to the point I'll say, Mr. Electrician, get your code book out and let me look this up for you and show you the code. And the next answer they give me, Ben, is always, I don't have a code book. And that's normally what I find is, they want to argue with you about something, but yet they don't even have a code book.
Don't even have a code book.
Most of the time, what Bubba taught them how to do it, that's how they do it.
Yep.
So, but yeah, it's a good question, guys. How about this one? I mean, we're not code inspectors, as Ben says, but I think you would be incorrect in writing up your report if you didn't write that up, is not having adequate working space. So, I mean, you can, there's ways you can do it, but if you say you don't have adequate working space and you don't have a code to reference it, then it's just your opinion. So, sometimes it's good to have those codes. I mean, not that you have to reference the codes every time, but, if you get in situations like this, it may be advantageous to you. Remember how I said the disconnects, they install them right behind the AC units? I see this is almost 90% of my inspection. New construction, used, it doesn't matter. The disconnects will be right behind the condenser unit. Well, if you're supposed to have a 30 by 36 inch clearance, that doesn't make it. Same thing on the gas meter. If that gas meter is too close to that AC system and you have a gas leak, and I had one at my own house here just recently, and me and the plumber had a time trying to find it because it was under the ground coming up. We finally had to dig the ground up, and we found where the pipes came up was damaged and we had to replace it. But if there's a gas odor out there and you take your gas sniffer and you try to check that meter, if you don't find it, if you got a gas odor, you probably still should write it up. But the inspector observed or noticed a gas smell while walking around the gas meter. But most utility companies in our area, the gas company requires at least a 36 inch clearance between the AC system and the gas meter. Yours may vary, so you'd want to check with whoever the gas or utility company is in your area for that number. This is just out of the code check book, and these little books are great. If you guys have never used these, you can buy these through iccsafe.org, probably just any bookstore, but they have different ones for different, for electrical, for mechanical, for plumbing, and for building, based on certain building code years. These things are great, and they've got really good illustrations in it. But if you notice how the disconnect switches, it says not to be installed behind the condenser. I mean, that's, yeah, that's it. Now, you know, on the bottom left, it says all ACs require an inside disconnect. Well, if on the right side of this or the left side, on the left side of this air conditioning unit we're looking at in this illustration, if there was a wooden fence and your electrical panel board's on that same side of the house, but it's on the opposite side of that wood fence, then this unit would still require disconnect, like you're seeing in the picture. Now, if that wood fence was on the right side, or if it was scooted back a little bit, even on the left side, and you had the electrical panel board there where you could see the AC condenser from the electrical panel board, it would not require a disconnect switch. That's because you have an inside breaker you can turn off of this unit. Okay, another one I find all the time. I mean, this I could probably just leave as a default on my computer, is a ground rod. These things are supposed to be buried below grade. Now, in some areas where you have basements, I know things vary in rocky formations, it all varies. But the typical ground rod is supposed to be buried 8 feet underground. Well, if you got 8 feet rod and it's supposed to be buried 8 feet, that doesn't leave 12 inches sticking above ground. So I don't know where these electricians get their math from, but in my area, I see this all the time. Today, in the new National Electric Code, there's supposed to be 2 ground rods installed. They have to be at least 6 feet apart and connected together. Now, some areas have the UFR or what we call a concrete encased electrode, which that's acceptable in some areas. In our area, we fight that with builders all the time because the concrete encased electrode is a piece of rebar. They turn up about 2 feet in the garage usually, and then run it in the grade beam of the slab. And they tell us, well, it's in touch with the ground, so it's considered a concrete encased electrode. Well, rebar is not something that's allowed to be used as a ground rod. So they're wrong in 2 ways, but we fight that continuously with builders here. But if they just put 2 ground rods in like the illustration shows, that's fine. That meets the National Electric Code requirements too. The other thing on older homes, I find this quite frequently, is the ground clearance if it's overhead service coming to the house. This is, I think, an illustration from NACHI. Yes, it is. And, you know, it's a good illustration to use, but this just simply shows you what the codes are on the clearances for electrical wires coming to a house. If you walk around the back of the house and have a wire run across the yard and you can reach up and touch it, that's too close. You don't want to do that. Okay. Another interesting thing, and I'll give you some code reference on some of this stuff, and others it's just information for you. But this is based off of Mike Holt. If you're not familiar with him, MikeHolt.com is a great website to visit and get on his newsletter. This guy is a genius on electrical, in my opinion. But if you know, a lot of times we'll walk in, we'll see a bathtub or shower, and we'll have a chandelier hanging over that bathtub. It looks real pretty. Yeah, from an inspector standpoint, you think, well, hey, we got a light over the tub. Okay. Well, the problem with that is if that light fell or someone got up, it was wet and touched that light and it was shorting out, it could electrocute them. The code itself says, as you see the illustration here, from the top of that tub, 8 feet up to be the bottom of that light fixture, and 3 feet from the tub is the direction. And as far as a plug being in that range, at the top of the tub, the plug can't be closer than 3 feet. So the illustration shows you there where it's at. So, you know, if this class is presented where you can copy these sometime or something off of it, feel free to use these things as your own illustrations. Here's what the code check does. I told you about the code check, how great little books it is. It shows the same thing, just a little different drawing on it. But it's an 8-foot, 3-foot rule on ceiling fans, light fixtures, anything like that. Now, if you get a light fixture that's over that 8 feet, like this can is, it's okay. But anything hanging down in that 8-foot range, it's a code violation and a safety issue.
And Paul, sometimes I hang out on Facebook and there's long discussions on InterNACHI's Facebook page about code and how to interpret code. I mean, it can go on and on and on about interpreting code. Some code is difficult to understand. Like there's a code in relation to the tub and shower about light switches. And the light switch, I think, is handled differently than a receptacle within that 3 foot, 8 foot thing, which doesn't make sense to me. But
Yeah.
it's
Well, and you'll find that. I mean, I had a discussion with a builder here in the Houston area, David Weekly. I don't know if they're nationwide. I think they probably are. But me and the guy that's over all their construction people, I wrote up they were missing an exhaust fan in the utility room. And the guy called me and said, Paul, he said, every time you inspect one of our new houses, you write this up. He said, it just creates problems. He said, we got to get to an agreement on that. So I said, well, I'll tell you what. I said, in all fairness, I said, instead of just taking my interpretation of the code, let's call ICC and get an interpretation. So he called ICC, called me back as proud as he could be and said, Paul, you are wrong. The ICC said they don't require it. I said, well, give me the name of the engineer at ICC you talked to. Let me call him, because not doubting you, but I just want to verify it from my own ears. So he gave me the number. I called, and the guy was busy. The guy, the engineer in his next little cubicle called, and he said, well, can I help you with something? I said, yeah. I said, here's the issue. And I told him what was going on. I said that they needed an exhaust fan in a bathroom, in a utility room, because of all the moisture from a wash machine, a dryer, and maybe a sink. And he said, oh yeah, absolutely. It's just always been like that. I said, I had David Weekly guy call, talk to your name. I gave the guy's name. He said, oh, he's in my next cubicle. Hold on, I'll go get him. So I hear him going over there, and he left the phone and put it on hold. He laid it on his desk. I could hear the two of them arguing. So here's two people at ICC arguing about the same code, and they had opposite opinions. So he comes back, he said, Paul, I guess we're going to have to agree to disagree. So, whenever you guys talk about codes and interpretations of it, this is a prime example. You can read it one way and get an interpretation. I could read it another way and say, no, it doesn't go like that. That's the way the codes are. Those are minimum. And all I can tell you, when you order your code books or something, get the one that has a commentary in it. That'll give you the code interpretation and a view on why they did that. And it's quite interesting on it.
Yep.
But order the books, guys. You won't go wrong on them. Now, they change every 3 years. So, I was going to tell you on the codes too, just to help everybody out. ICC has I take it back. I don't know if it's ICC or not. If you go to a Google search and search for free IRC codes.
Oh, that's right.
There is a free access to it. It's limited, but you can get reference on the codes. Like if you want to search for dryer exhaust vents or light fixtures, you can search on it, but it's a free access service that you can get in and do.
Yeah, that's you're right. International Code Council is a great partner with InterNACHI. Actually, they've given us permission to use a lot of their copyrighted things for our college to teach, and they put their code books all online, free to public access. Now you can't print from it, you can't copy it, and all that stuff. There's restrictions, but you can certainly refer to it. And if anybody has any problems trying to find it, just email our education team at InterNACHI, and they'll send you the link.
Yeah, that's invaluable. That's great. Good job, man. Okay, let's go on. All right, now, AFCI breakers. I don't know how familiar you guys are with arc fault circuit interrupters. This is not GFCIs. Those are a different type of a device, even though today you can get a combination AFCI and GFCI breaker unit for the panel board. But AFCIs, arc fault breakers, have become a very, let's just say it's very much involved in the breaker panel boards these days. It's required, if you look at the list on the right, all those locations require arc fault protection. Now, when you get to the kitchen, bathrooms, garage, other areas, the GFCI is going to be there, but arc fault protection is a biggie there. And this section 210.12 bracket B, that's in the National Electric Code. That's a reference there. Again, this came from Mike Holt's enterprise that I was telling you to look at his website. he's got a lot of good papers that you can study if you want. Yeah, just depending on how much you want to put in your business, how much knowledge you want on this stuff. It's limitless, guys. If you like to learn stuff, it's no limit to what you can do. This is just a sample. Now, if you notice where the red line is on this breaker, these are arc fault breakers. There's a little green test buttons. This was some of the first series that they came out with on breakers called arc fault. But if you notice that where that red line is there, it says branch/feeder. These breakers were designed just as a branch circuit feeder. This came out, this was the first series that the arc faults came out. Immediately, as soon as they started putting these things in houses and buildings, the breakers changed again. They went from an arc fault, a branch circuit, to what would be where the red line is now. It was a combination. So today, anything that's been put in, you should see combination. Branch circuits, they claim that they would trip, especially with the panel boards outside. They would cause all kinds of issues. I never experienced it. I've never run into an electrician that said, yeah, we have that problem. I think I would just say, I think somebody had a connection there where they could increase the cost of breakers and change it to a combination breaker. But they are something that's required on most 20 amp, 15 and 20 amp circuits today. So if you're doing a newer construction, I'd say within the past 6, 7, 8 years, you should have combination arc faults on them. GFCIs and arc faults change over the years. This is just a chart that shows you year to year how they started out from 71 down to 2014. 2017, it increased even more than that. But GFCI is basically covering everything anymore. In the garage, not only is the garage receptacles on the walls have to be ground fault protected, but even the one in the ceiling where the garage door openers plug in. So it's gotten to be ridiculous. I know my electrician, we're in the process of building, and the electrician working on my house today, as I was walking around showing him what I wanted done, I showed him my refrigerator location. I said, I do not want that on the GFI. He said, but that's a code. I said, well, I'm the code inspector on it. I don't want that GFCI on my refrigerator. I said, I like to keep my stuff cold when I'm gone. So yeah, you're going to find different places, but that's code inspector's interpretation, my own personal on that one. Okay, if you're doing any newer construction, and I followed behind an inspector up in our area recently on a new construction, and the builder had built it, but it was all kind of screw ups in the thing, electrical wise. I went in and I would have walls that was 12, 15 feet long that didn't have a plug on them. And the home inspector inspected it, didn't write any of this stuff up, but the home buyer had enough sense to realize, hey, I may want to put something right there and plug it in. What do I got to do? Use an extension cord? Well, that's the secret. We do not want them to have to use extension cords. So basically, that's how, if you think about it, if a typical lamp or TV set, whatever, can't plug in without using an extension cord, it probably ought to raise a red flag, and you consider the depth of what where the plugs and all would need to go. But again, this is just a reference for you. Again, this is out of that code check book. This is a little flip chart type deal you can carry with you, put in your vehicle or whatever to reference. And you don't have to have the whole code book. This will give you the majority of the things that you probably run into. That would be very helpful to you. Kitchen cabinets. This is one I find, as we do older homes and they remodel the homes, they don't remodel it. They don't bring the stuff up to code as far as electrical goes. When they remodel a home, like a kitchen, a total renovation, in my area, they're required to bring it up to current national electrical standards. So a lot of times I'll go back in, I say, wow, that sure is pretty tall on that backsplash, but Mr. Electrician, you didn't put the plugs in. So, sometimes I'm not a popular guy, but again, I'm just a reporter. I report what I see. So, the homeowner will appreciate you telling them that they need plugs where they didn't have them, especially when they start plugging things in. This is just an illustration out of the code check, again, to show you if you had a corner kitchen sink, where the plugs should be. So, just some interesting things that, you walk in, a lot of times we get busy. We try to get through with the inspection. We got things going on that evening. You know, these are just some illustrations to show you, make you stop and think, you know, there should be plugs there. This is just another illustration for the kitchen countertop. And this code check illustration, you can actually buy the disc and have those illustrations where you can use them. Okay, older homes in particular, you'll have a closet. This was a closet, had a metal clothes rod there at the bottom left, you can see. But see the light bulb? Closets that you can stack stuff up on a shelf. You know, people throw all kind of stuff, blankets, clothes. If it touches that incandescent bulb, what do you think is going to happen? Be a fire hazard. These types of closet lights today require a globe cover over them. The other thing that I find a lot of times, particularly in older houses, they'll have a pull string. And guess what that is? That's just a string. Well, that's kind of like a candle wick to me. If that bulb's left on in that closet, that string gets hot, it's going to ignite and it's going to cause a fire. So if you find something like that, definitely, if nothing else, recommend that the thing be changed out. The bulb, put globe covers on it, whatever. Just whatever comes, whatever you want to do, but something for safety for your clients. This is a code illustration, but you notice the bulb in the middle here, surface incandescent. They have a light globe cover over it. But there's the areas where if it's 6 inches out and it's recessed light, or 12 inches out and it hangs down, those are the areas where you need the globe cover on. So, you know, just good information to know. Now, this is another one that I find quite frequently in homes. These cans, these are your light cans. When you have recessed lights, this is what shows up inside the attic space. Notice how the insulation and the wiring and all is touching this light can? Well, the codes require 3-inch minimum clearance of any combustible material around those cans. Now, if you have the newer style cans, like we put in new construction, the cans are what we call IC. That means a big IC and a letter be on top of this can or written somewhere on them. That means you can cover them up. You can cover them up totally. But if you don't see that on them though, these older lights, they can overheat and they are a fire hazard condition. So, I mean, and if you're doing older homes, you got recessed lights, 99% of the time, this is what you're going to have. What do they do to correct that? Normally we'll take and push the insulation away, take a piece of cardboard, or I've seen people take a 5-gallon bucket and cut the lid off the thing and set it around these lights. Most will just take a cardboard box and cut it and make a circle where the insulation stuff won't fall down within the 3 inches around that light. So a lot of ways to do it. Just keep the stuff away from it. Smoke alarms, carbon monoxide detectors. Biggie, safety issues for inspectors. Smoke alarms today should go in every bedroom and in the hallways adjacent on each floor of the house. They should be hardwired, battery backup, and wired in sequence. What that means is if one activates, every smoke alarm in the house goes off. That's very much a safety issue. You can test these smoke alarms. I've had inspectors say, I'm afraid to test them. Well, why are you afraid? If it's got a test button, push the darn thing. I mean, that's the only way you're going to test it. Now, if it's part of the alarm system, it won't have a test button on it. And I can tell you now, you don't want to use smoke in a can. I've had inspectors spray smoke in a can at the smoke alarms, and they were monitored. Next thing they knew, sirens was happening. The fire department pulled up to the house. You don't want to go down that route, guys. I'm telling you, that's, you know, you can buy stuff that's just pure junk in our business. You don't want to do that. Simply, I've got an extendable mirror that I use. I can use it for looking under stucco or bottom of bricks or underneath a house or whatever, but it reaches about 4 feet. And what I do, I extend it and I take that handle, I'll push that button on the smoke alarm. Then I'll listen to see if they're going off all through the house. So that's a simple deal. Now, the other thing is newer codes now require carbon monoxide in a house. They started off with, if it had an attached garage, you had to have a carbon monoxide detector, or if it's gas in the house. Well, carbon monoxide is not a bad idea for any of them. So, yeah, it's a good recommendation just for safety for our people. All right, the biggest thing is, guys, in this business, you never want to stop learning. I mean, that's the fun part. I've been doing this 27 years, and I've done several things in my career that was totally opposite of home inspections. And I thoroughly enjoy doing inspections. I'm kind of getting wore out on climbing in attics and crawling around. Seems like the body parts don't last as much as the stuff up here does, you know? But I hope that this presentation will cause you guys to stop and think a little bit as you do an inspection, especially electrical, and stay safe. I want to thank you all for attending this webinar, and I hope you have safe inspections. All right, Ben, I'm turning it back to you, buddy.
All righty. All right. Thanks, Paul. I really appreciate it. And we had a ton of questions come in. There's no way I could answer them all. I shot Paul a couple really good questions. And everything's going to be video recorded. So if you happen to miss everything or you want to get the resources and watch it again, it'll be video recorded. And just email our education team if you have any problems trying to find answers to your questions or to watch the video again. Paul, I really appreciate it, buddy. Thank you so much. I'm glad we got the technology all figured out. It was all my fault, but I'll do better next time.
Oh, I enjoyed it, Ben. Thanks for inviting me to do this.
Appreciate it, buddy. See you later.
All right. Bye-bye.
Stay safe and healthy, everybody. Bye.